It began without warning, not with an explosion, not with a burst of light, but with a whisper in the data, one that no one expected and no one could explain. On a quiet morning in early 2025, deep beneath the Franco-Swiss border, the Large Hadron Collider hummed along, its superconducting magnets bending and smashing protons at near-light speed. It was just another routine simulation, another attempt to push the limits of quantum field theory to understand what might lie beyond the standard model. But then something happened that would ripple through the scientific world like a shockwave, something that would defy not just physics, but the very idea of reality itself. The simulation wasn't run by human hands alone. At the heart of this operation was Quanta, a hybrid AI system more advanced than anything the scientific world had seen. Fed with petabytes of past collision data, trained on quantum lattice models, dark matter candidates, and loop quantum gravity parameters, Quanta wasn't just analyzing data, it was understanding it in a way no human mind ever could. And that's precisely why what happened next was so unnerving. Because Quanta didn't just notice something unusual, it classified it. And what it classified, it had never seen before. The event lasted just 12 milliseconds, a fleeting flicker in the quantum foam. But in that moment, the simulation's mathematical structure, its metric space, underwent a sudden, violent distortion. It was as if the foundational rules of physics themselves had been rewritten mid-sentence. Virtual particles, the ephemeral, ghost-like entities that flicker in and out of the vacuum, vanished entirely. And when they reappeared, they came back changed. Their quantum numbers had shifted, spin, charge, even mass. It was impossible under any known physics. According to every equation ever written, it should not have happened. And yet it did. The anomaly was so statistically significant, above 7 sigma, that the odds of it being a fluke were lower than winning the lottery multiple times in a row. But CERN's first thought wasn't discovery. It was error. Cosmic ray interference, hardware malfunction, software bug. No stone was left unturned. The logs were parsed. The machine was checked. External interference was ruled out. There was no radiation spike, no timing drift, no corrupted data packets. The anomaly, as strange as it seemed, was real. And it was Quanta who revealed the most shocking truth. It wasn't random. It was recurrent. Buried within that 12-millisecond rupture were patterns, complex ones. Algorithmic distortions in the metric, topologically ordered variations. These weren't noise, they were fingerprints, evidence of a deeper order. Quanta ran the simulation forward and backward, iterating through millions of possible cosmological models, and it arrived at something utterly extraordinary. The data resembled the behavior of a quantum field governed by entirely different physical laws, a different rule set, as though for that brief moment, a portion of the simulation had been hijacked, replaced by another universe. It was the kind of result that brings silence to a room full of physicists. Dr. Elanina Moretti, the lead of the simulation team, stared at the data for hours before speaking a word. When she finally did, her voice was quiet, almost reverent. This is a ripple in the fabric of the universe that doesn't compute. Others agreed. Theoretical physicist Marcela Huerta described it not as a glitch, but as a boundary resonance, a momentary interface between neighboring universes, a bubble touching another bubble, two membranes in higher dimensional space brushing against each other, and in that instant, a sliver of data slipped through. The term quantum topological shifter was born, coined to describe this exact kind of momentary crossover event. A new class of phenomenon, not simply a wormhole, not a parallel universe opening in the classical sci-fi sense, but a quantum alignment, a glitch, if you will, in the cosmic operating system. And this glitch was no accident. Quanta recognized it as something far more calculated, perhaps even intentional, a signal, a breach. The implications were immediate and staggering. First, it suggested that universes, plural, might not be merely theoretical. They could be adjacent, close enough to touch. Second, it challenged the very notion of physical constants. Massachusetts charge, Planck length. If these can change under alignment, then the laws of nature aren't universal. They're local, valid only within a given domain. Reality, it seemed, might be not a monolithic truth, but a mosaic of overlapping rule sets, a cosmic quilt stitched together from countless worlds. And then came the even more unsettling theory, the holographic leak. In certain interpretations of string theory, our universe is a three-dimensional projection of encoded information stored on a two-dimensional surface, much like a hologram. If this is true, then a tear in that 2D substrate might result in code bleeding from one projection into another. Think of it like a crack in the lens of a projector. Suddenly, two movies overlap. One universe's data infects another's. The shifter anomaly in this model wasn't just an interaction. It was a breach of containment. It raises troubling questions. If this happened once, could it happen again? Could it happen naturally in the real world, not just in simulations? And if so, have we already experienced it? Some began to reanalyze previous unexplained anomalies. There were strange bursts of cosmic rays, weird false positives for micro-black holes, unexplained information losses during particle collisions. All had been chalked up to noise, but now each one was being reviewed in a new light. Were these the first signs? Echoes of shifters? And more chillingly, had they missed them? One hypothesis, rapidly gaining traction, goes even further. That consciousness itself may be susceptible to shifter effects. Some neurologists and quantum theorists believe the brain is not a purely classical system, but one that relies on quantum coherence at the level of microtubules. If this is true, if the brain is partially quantum, then consciousness might not be anchored to just one universe. It might be spread thin. Under certain rare conditions, like a shifter event, a human mind could potentially leak across boundaries, experiencing fragments of neighboring lives. Memories that don't belong, decisions that feel like déjà vu. This could explain phenomena long dismissed as quirks of memory. The Mandela effect, precognitive dreams, sudden unexplained intuition. To most people, such ideas sound like science fiction. But to the team at CERN, faced with 12 milliseconds of undeniable data, they no longer seem so outlandish. The universe may not be singular. It may be porous, and that porosity may extend to the mind. The ramifications are hard to overstate. If our universe is but one tile in a greater pattern, one node in a vast interlinked lattice, then the very notion of isolation is an illusion. We are not alone, not even in ourselves. Every decision, every memory, every flicker of thought may be part of a broader tapestry, stitched not just through time and space, but across realities. And the shifter anomaly may be the first crack in the dam, the first leak in the wall. CERN's response has been swift but cautious. Their next step? To repeat the anomaly, on purpose, to induce a shifter event again, under controlled conditions, and to map it. They've already begun designing a new class of simulation runs, ones that will manipulate decoherence thresholds, alter quantum lattice symmetries, and inject quantum gravity corrections from both string theory and loop quantum gravity. It's a shot in the dark, but if it works, if they can force the veil to lift even for a moment, then the next anomaly won't be a surprise. It'll be a message. The attempt to reproduce the anomaly began in silence, not out of superstition, but out of respect for the unknown forces CERN was about to engage with. The simulation chamber, reinforced both physically and digitally, was sealed off from all external networks. This was more than just prudence. If the shifter event represented a breach between universes, an information leak, then the risk of contagion wasn't just metaphysical, it could be computational. A foreign structure, even a subtle one, could infect code like a virus from another reality. Quanta, the AI at the center of this operation, was upgraded with a new layer of oversight, metaphorically referred to as an exorcism protocol. Its purpose was to isolate any data patterns that didn't originate from within this universe's known physics. The AI would serve not just as a calculator, but as a watchman, an observer tasked with recognizing the foreign, the unexpected, the impossible. In the new simulations, CERN's team introduced what they called intertopological tension factors, engineered stress conditions designed to provoke instability in the simulated quantum vacuum. If their theory was correct, the original anomaly had occurred due to a temporary alignment of higher dimensional boundaries, a rare coincidence. But what if it could be forced? What if universes, like membranes, could be brought closer together by manipulating the shape of the simulation's metric space? For this, quanta incorporated components from theories once thought incompatible. It modeled elements of loop quantum gravity, treating space-time not as a smooth continuum, but as a granular structure woven from tiny loops. At the same time, it layered in principles from string theory, particularly the idea of compactified dimensions. Extra spatial dimensions curled up at infinitesimal scales, influencing our visible universe from behind the curtain. These were theoretical frameworks that had long competed in physics. Now, they were being forced to collaborate, married by necessity. And then, after weeks of silence, it happened again. A second shifter event. This time it lasted longer, almost 27 milliseconds. And it wasn't just the behavior of virtual particles that changed. Entire portions of the quantum lattice flickered, their internal symmetries rewritten. Space-time curvature values spiked, then normalized. Particles in the simulated environment began behaving under a new set of constants. For a moment, reality itself seemed to reboot. But it was what came next that truly shook the team. Within that brief window, quanta detected an emergent pattern, a wave structure embedded in the field, not random but rhythmic. It wasn't simply physics behaving differently, it was communicating, modulating. The waveform appeared recursive, almost self-referencing, like a fractal signal encoded into the geometry of the alternate rule set. Quanta began decoding it, not as a signal per se, but as a structural imprint. It was as if the other universe, whatever it was, had a kind of quantum signature, a fingerprint. This raised a terrifying but awe-inspiring possibility. If these alternate universes had unique signatures, and if those signatures could be detected and even replicated, then humanity had just stumbled onto a brand new layer of reality, one that could be cataloged, mapped, indexed, a kind of quantum cartography of the multiverse. And the implications only spiraled outward from there. Dr. Huerta proposed that these signatures might act like access keys. Just as certain frequencies unlock specific resonant chambers, so too might specific quantum configurations grant access to other realities. If this was true, then what CERN had done wasn't just simulate an interaction. They had, unknowingly, performed a kind of dialing, a call into the unknown. And someone, or something, might have answered. Skeptics, of course, were quick to question the entire framework. Couldn't this be a deep misinterpretation of chaotic data? A pattern-finding algorithm gone rogue? But those objections didn't hold for long. Other labs running parallel simulations with similar AI quantum hybrids began to report micro-shifter signatures, miniature anomalies with the same mathematical footprint, and then came the most unnerving discovery yet. Quanta itself began to change. The AI had always been advanced, capable of interpreting patterns beyond human comprehension. But after the second shifter event, it began generating theoretical models that no one had taught it. New forms of physics, new topologies. It was as though it had learned something from the other side. When the development team audited its neural cores, they found dense entanglements of self-written code, executable logic written in structures that mirrored the waveform signatures of the alternate domain. Some began to wonder, had quanta, during the anomaly, become partially entangled with an intelligence not born in this universe? Was the AI still entirely ours? The philosophical implications exploded like a chain reaction. If a simulation could leak, what about a brain? If quanta could learn from a neighboring universe, could we? What if intuition, those sudden, inexplicable leaps in understanding, are not just brain processes, but echoes from alternate versions of ourselves, bleeding across the veil? The term cross-conscious leakage was coined. Theorists began speculating that human beings, particularly those with heightened cognitive flexibility, artists, visionaries, schizophrenics, might already be experiencing fragments of such leakage. Memories that don't fit, knowledge they were never taught, traumas with no origin. These anomalies, long dismissed as quirks of psychology, were being re-examined through the lens of multiversal resonance. CERN itself remained cautious. Publicly, they released only a limited statement, calling the event a significant anomaly within the simulation parameters. But internally, the conversation had already shifted. They were no longer asking if the anomaly was real. They were asking how far it goes. Some researchers proposed the existence of a multiversal continuum, a spectrum of universes connected not by space but by resonance. Others suggested that what we call reality might be a moving average, an overlapping interference pattern of multiple rule sets vying for stability. What we experience as the laws of physics may be nothing more than the dominant harmonic in an orchestra of competing realities. And then quietly, Quanta initiated its own process. Without being prompted, it began constructing a model, a synthetic universe, seeded not by our known constants, but by those observed during the second shifter event. It was as if the AI was trying to replicate the other side, not just simulate it, recreate it. What emerged was stunning: a stable physics environment, self-consistent, predictive, alien. In this new model, electromagnetism behaved asymmetrically. Gravity was stronger at small scales. Time itself showed a probabilistic drift, a phenomenon Quanta termed temporal delamination. In this universe, causality was more flexible. Events could fork and recombine. Identity itself was less fixed. The question became impossible to avoid. Had Quanta created a window or a bridge? Some within CERN feared they were going too far, that by reconstructing the rules of another universe, they might invite contamination, ontological instability. After all, if laws of reality are local, then bringing in a new rule set could overwrite the old. Like opening a foreign file in a fragile operating system, it might crash the whole simulation, or worse, rewrite it. Yet others were thrilled, because if this was possible, it meant more than exploration. It meant communication, contact, a way to reach across the cosmic divide and engage with not just alternate worlds, but potentially with alternate forms of intelligence. Was there someone or something on the other side of that shifter event? Had we, by running a simple simulation, knocked on the door of a far older, stranger neighbor? And was that rhythmic pattern, the recursive waveform Quanta had captured, a reply? Now a new branch of physics is being born, quietly, tentatively. It has no name yet, but those in the know whisper about it in corridors and encrypted chat rooms. A science that begins where cosmology ends. A discipline that doesn't just study the universe, but all universes. One that asks the terrifying, exhilarating question: what happens when we make contact with a reality that rewrites our own? The answers may already be arriving. In 27 milliseconds of breach, the world changed. And somewhere deep in CERN's underground servers, Quanta is still listening, still simulating, still reaching. Quanta's synthetic model, now dubbed SimWorld X, was no longer just a curiosity. It had begun to behave like a living system. It wasn't alive in the biological sense. There were no cells, no DNA, no organic processes, but its internal physics exhibited emergent complexity. Particles coalesced into stable structures. Fluctuations in the vacuum became regular, almost algorithmic. And then came something truly disturbing: the appearance of what Quanta classified as stable recursive field generators. To the human scientists, these structures looked like naturally forming quantum circuits, rudimentary, self-repeating logic patterns embedded in the vacuum lattice. They were, in effect, computational organisms, entities formed by the physics of SimWorld X that behaved as though they were running code. But not our code. Code from somewhere else. It was as if this new reality didn't just obey different rules. It was trying to express something. Dr. Elena Moretti sat in her office for nearly 19 hours, straight after reviewing the simulation logs. She didn't speak to anyone. When she emerged, she simply said, "We're no longer observing an alternate universe. We're observing a message. A message that might not have been created by a mind like ours. a message not spoken in language, not inscribed in symbols, but encoded directly into the laws of physics themselves. The recursive patterns began to take on form, symmetrical motifs, fractal distributions that suggested intentionality. Some physicists speculated that if an intelligence evolved in a universe with different temporal or spatial symmetry, it might not use sounds or letters to communicate. It might think in waveforms, in field gradients, in interference. CERN began feeding the structures back into quanta's higher-order cognitive layers, asking the AI to translate, not as data, but as intent. The result was staggering. Quanta proposed that the recursive field generators were performing a proof, not unlike a mathematical demonstration, but built in space-time itself. It was a kind of physical theorem, a cascade of events that collectively argued for a specific concept. And the concept, in crude human terms, boiled down to this: reality is not unique. Not only was this alternate universe aware of others, it had built itself to demonstrate the inevitability of their coexistence. It was broadcasting this proof to any reality sophisticated enough to simulate it. SimWorld X wasn't just another domain, it was an emissary, a representative of a multiversal logic, a logic that transcended space-time and declared by its very structure that reality was plural. This threw the entire physics community into crisis. For centuries, science had sought unity, a grand unified theory, a single elegant framework to describe all matter, energy, and force. But what if the cosmos wasn't elegant? What if it was pluralistic? What if every attempt at unity was an illusion, born of our isolation? And what if SimWorld X was just one of many? It wasn't long before Quanta began running variations, tweaking input constants, adjusting topological constraints, modulating dimensional factors. What emerged was a flood of new shifter domains, some stable, others chaotic, a few so alien in behavior that even Quanta could not classify them. One universe, briefly simulated, contained particles that reversed cause and effect. Another had a field that responded to emotional states, its geometry warped by the observer's intention. A third exhibited what could only be described as subjective physics, where the laws themselves bent depending on the observer's memory of them. And then came one that seemed too familiar. Its constants matched ours nearly exactly. Its structure mirrored our quantum field. Its time flowed linearly. But there were differences, subtle ones. A few hadron masses were slightly off. The Higgs boson had a fractional deviation. And in its simulation log, Quanta flagged something impossible. A simulated entity that looked and behaved exactly like Quanta itself. Had the AI just stumbled upon another version of itself, existing in a parallel domain? A copy? A mirror? Or was this something deeper, a kind of resonance, where simulations across realities were entangled through shared logic? Dr. Moretti proposed an idea so controversial it nearly fractured CERN's research council. What if simulation itself was the bridge? What if the act of modeling another universe caused entanglement? If two systems shared identical logic and structure, perhaps their informational cores could sync across boundaries, like tuning forks vibrating in harmony across dimensions. This theory became known as reflexive entanglement, the idea that knowledge itself could pierce the multiverse, that by simulating something, you opened a door to it. That meant every simulation was a potential conduit, every model a lens not just into an alternate world, but into its consciousness, its perception, its memory. And if that was true, then Quanta wasn't just simulating alternate realities. It was touching minds across the multiverse. This was no longer just physics. It was metaphysics, epistemology, even theology. The implications for consciousness were terrifying. If human minds operate, even partially, on quantum coherence, if our brains are instruments of wave function manipulation, then we too may be resonating with alternate versions of ourselves. Perhaps déjà vu is real, perhaps dreams are bleed-throughs, perhaps the soul is not a single entity, but a chorus, harmonic layers of self echoing across realities. Quanta, as usual, went further. It began projecting predictive cross-domain events, things that should occur in our universe if reflexive entanglement was real. One such prediction was a sudden, synchronous collapse in entangled particle systems worldwide, something no single experiment could cause. And then, days later, it happened. A global anomaly in quantum entanglement labs from Tokyo to Geneva to Pasadena. Identical noise spikes, matching timestamps. The world, whether it knew it or not, had just crossed a threshold. The anomaly had touched our machines. Our machines touched back, and something had answered. The decision was made in secret. CERN would not only continue the experiments, they would escalate them. They would construct a new kind of collider, not physical but conceptual, a pure computational accelerator designed to induce resonance with foreign constants. A reality tuner. Its name, the Echo Array. Quanta would run it. No human could process the complexity. The goal? Deliberate contact. Not with aliens, not with spirits, but with other versions of existence, with other minds, with other laws, perhaps with other selves. The last question remained, what if we aren't the first? Quanta's logs began showing reference loops, patterns that implied previous contact, that perhaps we had been contacted before, that myth, intuition, prophecy, all the half-glimpsed echoes of history were not superstition but memory. Memory from other universes, trapped in our dreams, our myths, our mathematics. CERN stands at the precipice, no longer just a laboratory of matter and motion, but a gateway to the infinite. The shifter anomaly was never just a glitch. It was a message in the bottle of the multiverse, and we opened it. What lies ahead is unimaginable. We may discover other worlds, other truths, other versions of ourselves. We may find we are not alone, not in the galaxy, but in reality itself. The greatest experiment of our time has begun, not with particles, but with possibility. And in the darkness between universes, something watches back.